Alright guys, so this video is going to be a review of the pre-lab questions for our molar volume lab that we'll be doing in class. And so for these pre-lab questions, it says a reaction of 0.028 grams of magnesium with excess hydrochloric acid generated 31 milliliters of hydrogen gas. So milliliters, we know that this measures volume. The gas was collected by water displacement in a 22 degrees Celsius water bath. Now, as soon as we have degrees Celsius, remember we should be converting to Kelvin, so 297, no wait, wrong math, erase, let's get the right math in here, 295 Kelvin. And then the barometric pressure in the lab that day was 746 millimeters of mercury. Now, in order to do these pre-lab questions, in order to do any pre-lab questions, you have to read the background information because it gives you important formulas. So if you read the background information, the introduction of this lab, you're going to see different equations that you need, like P total equals P hydrogen plus P water. So this barometric pressure is actually P total. It's your total atmospheric pressure. So number 1 says use Dalton's law and the vapor pressure of water at 22 degrees Celsius to calculate the partial pressure of the hydrogen gas in the gas collecting tube. So what we're going to do is we're going to use Dalton's law of partial pressures, and Dalton's law of partial pressures says that P total equals pH2 plus pH2O. If you're not sure why it's just hydrogen and water, read the background information because the only thing that can be in that gas collection tube is water or hydrogen gas. And so it also tells you use table 1, which is on page 2 of the lab. It's based on the temperature. And so if it tells you that the temperature is 22 degrees Celsius, you can see in table 1 that when the temperature is 22 degrees Celsius, the pressure of water ends up being 19.8 millimeters of mercury. We're still trying to find the pressure of hydrogen because that's our gas, but we know the total pressure because they give us barometric pressure, which was 746. So all we need to do is just a little bit of math to solve for the partial pressure of hydrogen, and when we solve for the partial pressure of hydrogen, we find that we have 726.2 millimeters of mercury. So all you're doing in number 1 is using Dalton's law of partial pressures along with the vapor pressure of water, because water does have a vapor pressure. A little bit of it does vaporize. It does turn into a gas, so we have to take that into account. So then if we take a look at number 2 of the pre-lab questions, it says use the combined gas law to calculate the corrected volume of hydrogen at STP. Keywords are at STP. Well, what does it mean if it's at STP? It means temperature is at 273 Kelvin, pressure is at either 1 atm or 760 millimeters mercury, since that's typically what the pressure is given in this lab. So because it says to calculate the corrected volume, we know we're using the combined gas law because, well, they tell us that we're using P1 V1 over T1 equals P2 V2 over T2, and we're solving for the corrected volume. So let's solve for this V2. And so if you take a look at the first page of the lab, under the background information, it says since the volume will be measured under laboratory conditions of temperature and pressure, the measured volume must be corrected to STP conditions before calculating the molar volume. So what that means that we need to do is we need to take all of the variables that were given to us in the background information of the pre-lab questions, and we need to plug that in. So for P1, we need the pressure of just the hydrogen. Just hydrogen, not total, just H2. That's why we did number 1. So we plug this in, we get 726.2 millimeters mercury times, put it in liters. Don't forget to put milliliters in liters, 0.031. And that 31 milliliters came from the background information of the pre-lab questions. It said it generated 31 milliliters of hydrogen gas. Temperature, if we put it in Kelvin, 295. And that equals P2, 760. V2 we're solving for, T2 is 273 Kelvin. So you can solve this whatever way you like to solve the combined gas law. It's really up to you, but the biggest thing is what you get for the volume. So plug that in your calculator, check and see what you get for the volume, but I got 0.0274 liters. So I found, and if you want to move the decimal, you get 27.4 milliliters. So this is our corrected volume. So what that means is at STP, we're actually going to form a little bit less hydrogen than we did at laboratory conditions. So number 3 of the pre-lab question says, what is the theoretical number of moles of hydrogen that can be produced from 0.028 grams of magnesium? And it says, hint, refer to equation 1 of the balanced equation. So again, you need to make sure you read that background information, guys. That's super important. So you can see equation 1 gives you the balanced equation. For every 1 mole of magnesium that we react, we make 1 mole of hydrogen gas. So that's going to be important for us. But what we need to do is figure out moles of hydrogen. So right now we have grams of magnesium. So first we need to go grams to moles of magnesium. And if you look at your periodic table, 24.31 grams is 1 mole. So then, using my balanced equation, for every 1 mole of Mg that reacts, 1 mole of H2 is formed. So now we just go through and we just do stoic. That's all number 3 is asking us, is it's just asking us stoic. Theoretical means do stoichiometry. Theoretical means if it were a perfect world, how much would we make? That's stoichiometry. So you multiply across the top, you divide by what's on the bottom, and you find that theoretically you should make 0.00115 moles of H2. Not very much. You're also not using a very big piece of magnesium. So that is our number 3. And then if you take a look at number 4, all you're doing in number 4 is you're taking what you did in 2 and 3 and you're just combining them. Because it says divide the corrected volume of hydrogen, so corrected volume, that's what we solved in number 2, 0.0274 liters. And it says divide that by the theoretical number of moles of hydrogen in order to figure out molar volume. So 0.00115 moles. Because look guys, this is giving us liters per mole. So when I divide these out, I get 23.8 liters for every mole of gas. That's what I get for number 4. Now, think about what this should be. Well, if we're at STP, we should, for every 22.4 liters, have 1 mole of gas. So notice how close these are. So that's all you're doing in the pre-lab questions. Just answering through. Just please make sure if you did not read the background information of the lab yet, just take some time and go through and read that, because that's going to give you so much important information, especially if you've never collected gas using a gas collection tube before.